In this video, we're going to look at using electric circuit calculations and also what we know about current and voltage in series and parallel. So yeah, let's get started. In the first question, it tells you to find the total resistance of the circuit. It's giving you the EMF. EMF is a little different to the voltage of each individual component. Actually, it's the voltage of all the components in the circuit added together, because the total voltage, the EMF, is split up across all the components of the circuit. It tells you the current through the ammeter and the current through the whole circuit is 2 amps. I'm going to just quickly increase the thickness of the pen. And actually, because we already know the total voltage and the total current flowing through the circuit, we can rearrange the equation V equals IR to get resistance equals voltage over current. We can divide the total voltage in the circuit by the total current in the circuit, and that will give you the total resistance in the circuit, which is 5 ohms in this case. It then tells you the resistors W, sorry if it's a little bit small, but W, X, Y, and Z all have the same resistance. We don't know that yet, the resistance yet, so let's all call them resistances of capital R. It says show your answer is consistent with each resistor being 3 ohms. What you want to do is form an equation for the total resistance in terms of R and make it equal to 5 ohms, because we know the total resistance is 5 ohms. So first of all, W and X are in series, so we can find the total resistance across them by doing R plus R, which is just 2R. The combination of these two is in parallel with this resistor Y. We know that in parallel, 1 over the total resistance is 1 over the first junction that's in parallel plus 1 over the second junction that's in parallel. In this case, that's 1 over 2R, which is the combined resistance of this upper junction. So 1 over 2R plus 1 over the resistance across component Y. Now, when adding these together, there's a little trick, which is that, you can change the denominator here to 2R by multiplying top and bottom of the fraction by 2. The reason why we do that is now we can add the fractions together because the denominators are the same. So 1 plus 2 is 3, so that becomes 3 over 2R is equal to 1 over the total resistance of the parallel combination, in which case the resistance of the parallel combination is just the reciprocal, because you have to do the reciprocal of both sides to get the actual resistance. So that's 2R over 3. Now that we've got the total resistance across this whole junction on the left, we can now add it onto resistor R, which is in series with this whole junction on the left. So let's do that. So 2 over 3R plus R is equal to 5 over 3R. How I know that is, again, in order to add a fraction to a number, you can make it so that the whole number is a fraction that has the same denominator, because we know 3 over 3 is just 1, and then 2 plus 3 is 5. Now we know the total resistance is equal to 5 ohms, and then we can rearrange that to find the resistance of each individual component. Start by multiplying both sides by 3, so 5R is equal to 15, then divide both sides by 5 to get the resistance of each individual component is 3 ohms. So that's your answer to that question there. It then asks you to find the current through resistor Y. Let's erase some of this information just because it's getting a little bit messy. So we know the total current going into the junction is definitely 2 amps. But what do we know about current in parallel? And actually, there's something that I used to remember this. I might as well just show you guys up here. I used to remember that in series, currents... let's write here series, and let's write here parallel. I used to remember that in series, current stays the same, whereas voltage splits up in series. On the other hand, current splits up in parallel, and voltage stays the same in series. So the voltage that goes in, the current that goes into this junction, it splits up because this is a parallel junction. But how does it split up? Well, now that we know each of these individual components are 3 ohms, in the top of the junction there's a combined 6 ohms, and at the bottom of the junction there's a combined 3 ohms. How current splits up is it's inversely proportional to resistance. That means that where there's 2 times less resistance, that component there will receive 2 times more current. So the lower junction receives 2 times more current than the upper junction. That means that we have to split the current up into 3 parts by dividing it by 3. So 2 over 3, 2 over 3, 2 over 3. And we say that 2 of those parts flow through where the resistance is less, because they're inversely proportional. So flowing through Y is going to be 4 over 3 amps. And by nature, through the top of the junction will be 2 over 3 amps, because there's 2 times more resistance at the top, so 2 times less current. But that's not related to this question. That's just so you guys are aware. Now the potential difference across resistor W, well actually it does help here. Now that we know it's 2/3 amps flowing through the top, That's the same across both W and X because we know that in series current is the same. On top of that, we also know the resistance across resistor W. So since we know the current and resistance, we can use voltage equals current times resistance. We can multiply the resistance current across W by the resistance across W, which we know is 3, and that'll get you 2 volts. And that's the answer to that. Quite a few calculations here. You might want to make a note of this table, but yeah, thanks for watching and hope the video helped. Thanks for watching. I hope this video helped. If you have any tutoring inquiries, be sure to visit my website www.excellineducation.co.uk. It's on the first link in the description too.